Welcome to Operations 1401, Operations Management 1. In this video, which is titled Chapter 2, Exercise IR2A Part 1, we're going to be going through the math for the first part of the forecasting unit. Where you're going to find this is in assignments, chapter exercises. You're going to go to Chapter 2, Forecasting Part 1, and you're going to click on Exercise IR2A. You can open that up, which I've already done here, and I've added some other stuff in just to help the learning. So this is it over here. And the first thing is we're forecasting heart transplants. And we want to forecast in year 6 using a 2-year moving average. So in the example or in the description, I'll always tell you what method you're using. So you're using a 2-year moving average. So this means I need the past 2 years in order to make a forecast. Well, if I'm in time period 1, am I here? I don't have 2 past years, so I can't make any forecasts. So there's nothing to fill out here. I come in year 2, and if I look in year 2, from this time period here, in year 2 I only have 1 past data point, so I can't make a prediction here either. But now, if I come in year 3, which is over here, in year 3 I can make a prediction because I have 2 past years of data, which is what I need. So what do I do for a moving average? Well, in this case, one second here, I'm trying to get the equation symbol to come up. There we go. Okay, there it is. So I'm going to take 45 plus 50 and divide by 2. Let's make this bigger so that everybody can see it. So this is exactly what's going on here. So in order to predict, and usually the prediction will call it F. So my forecast for time period 3, that's what the 3 stands for, the third time period, here's year 3. I'm going to take what actually happened in time period 250, what actually happened in time period 145, add them up and divide by 2. So it's a 2-year average there. And if I do the math, plus 50 divided by 2, I get 47.5. Fill that in. And let's continue on here, actually. So now I want to predict what happens in time period 4. So this here is my F4. What happens in time period 4? I need to take the last 2 years, which is time periods 3 and 2. And you'll see it's 50 and 52. So here I would replace the 45 with the 52. So 52 and 50. Divide 52 plus 50 divided by 2, and that equals 51. So this is why it's called a 2-year moving average. It takes the past 2 years, it averages them out, and it keeps on moving, sliding down. So hence the term 2-year moving average. So if we slide down now again, and if we're going to predict what happens at time period 5, here the last 2 data points are 56 and 52, so I'll update this. Plug it into your calculator, and F5, which is right over here, is going to be, if you plug it into the calculator, you should get 54. And finally, the one that we actually were asked to in year 6, what do you predict? So here I don't have what actually happened. So this is the point of a forecast, is to make a prediction. So what's my prediction going to be? Well, it's going to be on a 2-year moving average. So this is, I'm going to predict what happens time period 6, and it's going to be 57 and 56 because I slide this down. So I'm going to predict 56.5. So my prediction here would be 56.5 heart transplants based on the 2-year moving average. Now, you have here what's called the absolute error, and this is how far off was my forecast from my prediction. So what happened here was 52. Actually, let me change the box. So 52 is what happened. 47.5 is what I forecasted. What's that difference? So plugging that into my calculator, I'd get 52. I take away what actually happened, 47.5, and that difference, 4.5, that's my absolute error. Now, by absolute, I mean that I don't care if I was above or below. So if this gave me a minus 4.45, I would just lop off the minus sign. I'll just care how far away I was in my estimate. I don't care if I was above or below. So similarly here, 56 minus 51, that difference, which is 5. Had it been negative 5, I wouldn't care. I just want to know how far off I am. And here, 57 minus 54, that gives me 3. Just to reiterate what I did there. What actually happened was 57. What I predicted to happen was 54. And when I subtract 57 minus 54, I get 3. And I can't make an absolute error here because what actually happened hasn't happened yet. So there's nothing to fill in over here. And so I have my errors here. I have 4.5, 5, and 3. So now I want to calculate my mean absolute deviation. And what my mean absolute deviation is I'm going to take all the errors that I have, the deviations. They're absolute, so if it was negative, I would just make them a positive. I'm going to add them all together, and I'm going to divide by the number of errors that I have. So my MAD is going to be 4.5 plus 5 plus 3. And I divide by the number of terms I have. So let me actually do that here. Let's just change the box so that you can see. So here I have 3 terms. So opening up my calculator, (4.5 plus 5 plus 3 is 12.5 divided by 3 is 4.17. I'll make this a little bigger so it's easy for you to see. So my mean absolute deviation is 4.17. So a couple things. The best MAD that I could ever get is 0. Why? Well, if I had predicted 52 and 52 happened, then the difference here would have been 0. If I had predicted 56 and 56 happened, it would have been 0. If I predicted 57 and 57 happens, it would have been 0. If I go 0 plus 0 plus 0 and divide by 3, it's 0. So the lower the MAD is, the better that this forecasting method we used was in predicting our value here. So in our case, obviously we had errors, which was 4.17. So using a 2-year moving average, we had 4.17. And now we'll do a weighted moving average next, and then we'll do exponential smoothing. And then we can compare all the methods using the MAD to see which one is the best. And in this course, we're always going to take the lowest MAD as the best estimate. So that's moving average. Now let's look at weighted moving average. So in this case here, we're not going to treat all the weights equally. We're going to weight them. So I'm going to give you weights here, t minus 1. T minus 1 means 1 period ago. T minus 2 means 2 periods ago. And T minus 3 means 3 periods ago. So this is the T minus 1 weight we would apply to the closest one, the T minus 2 to the second, and so on and so forth. So if I take this box here and I move it down, you'll see that this is a 3-year moving average. We need 3 past data points. This means that we don't have any predictions for the first 3 years. So the first prediction we can make is F4. So in F4, and what do we do? So in F4, we're going to start with 0.6, which is our weight for the previous period. So at time period, we're in time period 4. 1 period back, time period back is going to be time period 3. So we're going to do 0.6, and we're going to multiply that by 52. And to that, we're going to add 0.25. This is what happened 2 periods back. That's why the t minus 2 is 2 periods back, 0.25. And I'm going to multiply that by what actually happened, which is 50. And finally, I'm going to add to that 3 periods back, t minus 3, the weight, 0.15, multiplied by 45. So this is my prediction F4. I'm going to take the weight, 1 period back, 0.6 multiplied by 52, add to that 25% of 50, add to that 15% of 45. I have to plug this into a calculator to figure this one out. So we get 0.6 times 52 plus 0.25 multiplied by 50 plus 0.15 multiplied by 45, and we get 50.45. So 50.45 is our answer here. So that would be our forecast for period 4. How far off were we? Well, we'd have to subtract 56 minus 50.45. So if we subtract 56 minus 50.45, we would get and just because I don't want to make a silly math error here, 56 minus 0.45, 5.55. This is how far off we were, 5.55. Now, it's called a 3-year weighted moving average. The weights stay the same, but they slide. So when I slide this down, I'm going to slide this down so that I can figure out F5. So what is F5? 0.6 multiplied by, so the weight 1 period back, 0.6. What happened 1 period back for F5 is 56. 0.25 multiplied by what happened 2 periods back, so that's 52. 0.15 multiplied by what happened 2 periods back, so that's 50. And there's our formula for figuring out F5. Plug it into our calculators. 0.6 times 56 plus 0.25 times 52 plus 0.15 times 50. And we get 54.1. How far off were we in our prediction? So we're going to take what actually happened, 57, subtract by what we forecasted, 54.1. And in this case, we get 2.9, but again, I don't want to make a silly error. 57 minus 54.1, 2.9. Finally, what are we going to predict for F6? So F6 is our next prediction. So we're going to take our 3-year weighted moving average, slide it down. So 0.6 is going to be by what happened one period ago, so 57. 0.25 times 56 plus 0.15 times 52. Plugging this in, we get 0.6 times 57 plus 0.25 times 56 plus 0.15 times 52. We end up with 56. So calculating this all out, we end up with a prediction of 56. We don't have what actually happened. That's why we're doing the forecast. And we also can't calculate an absolute error because there is no actual value. So what's our MAD in this case? Our MAD is calculated the same way. We take our two absolute deviations, which in this case is 5.55, 2.9. Since there's only two terms here, we divide by 2. So that's our MAD. Plug that into our calculator, we get 5.55 plus 2.9 divided by 2. We get 4.23. So which one would we want to use? The 3-year weighted moving average or the 2-year moving average? Well, the MAD here is 4.23. The MAD here is 4.17. I know that the smaller MAD means that I was more accurate or closer to my target. So right now I would choose the moving average over the weighted moving average because it's got a smaller MAD. And I'd like to point out here as well that the answers are always available to you. So if I go and I unhide the sheet, the moving average solution is right here, and it came up with the same numbers that we just got in the 4.17. The weighted moving average solution came up with 4.23 and made our same predictions here as well. So the solutions are always available to you. Again, I don't like showing you the solutions till you at least attempted them, but you can always unhide the solutions to take a look at them. Finally, we have exponential smoothing. So in this case, we need a different formula. We need this formula over here. So let me start it over here, and you'll see what we're doing. So what I want to do is, in fact, we have year 1. We have 45. So this is, let's put this here, 45 heart transplants. This is AT. So heart transplants, A stands for what actually happened. And the forecast is FT. So the heart transplants are what actually happened. The forecasts are what forecast to happen. And so my formula here is what happened, so I'm forecasting, let's put in a T. So I want to forecast for time period 2. Well, if I put in forecast 2, 2 minus 1, 2 minus 1 is 1. Alpha has to be provided. This is also 2 minus 1, so this will be 1. 2 minus 1 is 1. So for me to predict what happened in forecast time period 2, I'm going to start with what happened in time period 1. So I'm going to just copy this down so that you can see this. So what did I forecast for period 1? I forecasted 41. F1 here is 41. So we always need, when we do this model, we need an initial forecast, else we can't get going. What's AT minus FT? So what actually happened is 45. What I predicted to happen is 41. So this is 45 minus 41. So 45 minus 41 is 4. And absolute error, all I mean there is that if this was a negative, I would take it the negative away. So the absolute error is going to be the same as, in this case, it'll be 4. But if it was a negative 4, I would just make it 4. So I just take the absolute value. Now I have everything I need. I'm saying forecast year 6 using the exponential smoothing average with an alpha of 0.75. So here I gave you the alpha is 0.75. So use 0.75. And A1 minus F1, well, we just calculated that here. So this was A1, 45. This was F1. When I subtract those two, I can actually just read it from the table, and I can put it in here. So A1 minus F1 is 4. So now I have enough here to do my my calculation. So I'll bring out the calculator. So my forecast for time period 2 is 41 plus 0.75 times 4, and that gives me a value of 44. So my forecast F2 is 44. Now I can calculate A2 minus F2, so 50 minus 44. I know that's a 6. Furthermore, the absolute value of 6 is 6. So now I have enough to calculate F3, which is right here. So how do I calculate F3? Well, F3 is, start with what happened 1 period ago. So that would be F2 plus alpha A2 minus F2. So I'm going to try to predict F3. I'm going to start with what happened in time period 2, which is 44. The alpha stays the same throughout. It's always going to be 0.75. And A2 minus F2, in this case, it's 6, which I read right off the table. So in order to predict this, it's 44 plus 0.75 times 0.6, or another way to look at that would be this, 44 plus 0.75 times 6. Now I'll leave that up here for you. Do a calculator, and I get 44 plus 0.75 multiplied by 6, 48.5. F3 ends up being 48.5. AT minus FT, so that's 52 minus 48.5. That should be 3.5. Again, it's positive, so I'm going to keep 3.5. Couple things to figure out, or I want to point out now. So what's going on? So first off, I always start, so here, for example, I started with what happened before, 44. And if I look at this time period here, so let's look at these two values. So 50 minus 44. Was my prediction too high or too low? So I forecasted 44. What actually happened was 50. So I was too low. So because I was too low, when I need to make my correction, I have to come up. So when I do 50 minus 44, I get 6. So when I plug that in, I'm going to come up. And how much am I going to come up? Well, that's going to depend on the alpha. So if I come up with an alpha of 0, So if I were to use an alpha of 0, I would stay at 44. If I would use an alpha of 1, I would correct all the way up to 50. So alpha is basically how nervous I am. So I'm starting at 44. I'm going to correct. In which direction? I'm going to, well, if it was a negative sign, I'd correct down. So if this was, if I was too high, so if this was 56, for example, and this would have been a negative 6. And now, when I put a negative 6, I would have actually, this would have been minus 6. So this would have corrected down, and it would have started at 56 minus 56 plus 0.75 minus 6. So my prediction here would have come down from 56. So a couple things that are important here is the sign. If there's a negative sign, you have to leave the negative in because that corrects up or down. So let's change it back to 45 and 6. So it corrects up or down. You start with your previous forecast. Depending on your alpha, if your alpha was 0, you would never correct at all, and it would just stay the same all the time. If it was 1, you would just basically using the naive forecast. So usually you're somewhere between 0 and 1. This tells you how much you're going to come back. So this is why we get 48.5. So this is how the exponential smoothing is doing. It's using the error and the direction of the error to make the correction here. So now we have to calculate, and this we ended up calculating here was F3. Excuse me, F4. No, F3. 3 was 44 plus 0.75 times 6, which was 48.5. Now my next one is I want to calculate F4, which is this guy over here. So how do I calculate F4? I start with what I predicted in F3, and then I use the error on F3. So F3, I predicted 48.5. Alpha stays the same as 0.75. My error here was 3.5, and because I was too low, I'm correcting upwards. So 3.5. And when I do the math here, and now I'm actually, excuse me here, I'm predicting F4. I should have calculated that. So F4 is what I'm predicting, so I'm using F3 plus the error. So I start with 48.5 plus 0.75 times 3.5, and I get 51.125. Or maybe I'll just say 51.13 just to make it a little easier. What difference is there here? So my difference here is I was off by 56 minus 51.13. So my difference here is 4.87. And again, it's positive because I was too low. So I'm going to have to correct up again. This is the same. Let's calculate F5. So I'm going to start with what I predicted for F4 and then the error that I made in the 4th time period. So 51.13, 0.75 times my error, which is 4.87. So 51.13 plus 0.75 times 4.87, and I get 54.78. How far off was I? So 57 subtract 54.78 gives me a difference of 2.22. Again, in this case, the absolute error is the same as the error because I was too low. And the last one, The one finally that we need to forecast because we don't have it is to figure out what happened in F6. So to forecast what happened in F6, I'm going to start with what I forecasted in F5 and then take the error in the 5th time frame. So I end up with let's put in the numbers here, 54.78, 75, and then 2.22. Calculator up. So 54.78 plus 0.75 times 2.22. We end up with 56.45. And we can't calculate an error because we don't have an actual value, so these remain empty. So here we would predict 56.45. Now, what's our MAD? So our MAD is the same thing as before. We're going to take all our absolute deviations. In our case, 4. 4 plus 6 plus 3.5 plus 4.87 plus 2.22, and divide that by the number of terms we have. In this case, it's 5. So in this case, we get 4 plus 6 plus 3.5 plus 4.87 plus 2.22 for a total of 20.59. Divide by 5, we get 4.12. So here, my MAD is smaller than 4.17. It's also smaller than 4.23. So out of these 3 methods, it seems like the exponential smoothing gives us the closest values. So we would say that the exponential smoothing, or we would go with the exponential smoothing because it has the smallest MAD. If we unhide, the answers are available here as well. You might notice again that these answers are not rounded, so you might get rounding errors because these numbers here are not rounded at all. So if you're off by a little bit, it's probably a rounding error, which I explained in the first unit as well. So that's forecasting IR2A. I really, really, really want you to do assignments, chapter exercises, forecasting, and do IR2B and 2C if you need to. The reason that I want you to do this one so there's exponential smoothing, and if I unhide the answers here, you'll notice that a negative value comes up. So here, when we made a prediction, we were above, so we had to go down. So the exponential smoothing corrected for that. You didn't see that in this exercise, you see it here. So make sure that you go through this exercise, that you can do this exercise for the exponential smoothing, and that you understand it. Any issues, you come visit me during the office hours, which are on Thursdays from 1 to 1:50. So that's it for forecasting part 1, exercise A, part 1. Please make sure to do these exercises. Do exercise B, do exercise C if you need to. Any questions, come to the office hours, and I'll see you in the next video.